I'm Tammy Kolda, an applied mathematician, and this is Unlocking LaTeX Graphics. On this YouTube channel, I am providing a detailed how-to guide on using TikZ and PGF plots. I'm a longtime user of these tools, so I understand your frustrations. We're working our way through the contents of my book, Unlocking LaTeX Graphics, which is linked in the show notes. We're also working through some bonus material. Today's topic is drawing grids. We've already been using grids in the form of help grids throughout this series of videos. Today we'll dive in a little more deeply, investigating perhaps unexpected behavior, as well as a funny bug and a workaround for it. I'm assuming you're already familiar with TikZ. If not, go back and watch my previous videos linked in the show notes. As usual, we'll create our document today at overleaf.com. We'll click on New Project, then Blank Project, and then we'll type in the name Grids in TikZ LaTeX Graphics and go ahead and create that. We'll add the usual packages, overwriting what they already have here. So we use TikZ, which we need, of course, because that's what we're talking about today. The other packages, parscript and full page, are just to make things look nice, and hyperref is so that I can link the author back to the YouTube channel. Let me also go ahead and close this left thing and put the size over here to 150% so that you can see what's going on. To get started, I'm going to paste a section of code and compile it, and then we'll talk through it. So we're going to do a grid. And here we're doing a 3x3 grid colored in orange. For reference, I'm drawing a line that starts at 0, 0 and goes to the point 4, 4. And you can see it goes diagonally through the grid corner points as we would expect. Now we can change this 0, 0, which is implicit here since I didn't put anything. It starts at 0, 0. We can change this to be 1, 1. When we do that, then we get this grid that now goes from the point 1, 1 to the point 3, 3. So it's only a 2x2 grid. If I want to make it a 3x3 grid, I can make 3, 3 a relative point by adding plus or plus plus in front of this. In some ways, the grid is like the rectangle. You specify the starting coordinate and the ending coordinate, which can be explicit or relative. However, in other ways, the grid is very different from a rectangle. Let me give you another example to illustrate that. So here's a grid with non-integer endpoints. So let's scroll down a little bit. This is still the same diagonal line. Now I'm starting my grid at 0.3, 0.7, so a non-integer point, and I'm doing what I thought was going to be a 3x3 grid. It turns out that this is revealing the underlying grid of size 3x3 starting at that coordinate. It's not drawing a 3x3 grid that starts at that point. That might be a little bit confusing. If instead you really want a 3x3 grid starting at that point, you must instead use Shift. And we talked about that in the last episode. Let me give you an example here. So here's a grid with non-integer endpoints and a shift. Now the shift goes here in the draw command for the grid. And now it starts at that unusual point, 0.3, 0.7, and it draws a 3x3 grid starting there. So that's how you get around that. Let's talk about making grids with different step sizes. The default step size is 1 centimeter. We can change that using step, X step, or Y step. So an example here where we set the X step to 1.5 and the Y step to 0.5, the result over here is a grid that goes from 0, 0 to 6, 3. It takes 4 steps in the X direction and 6 steps in the Y direction. We can also just change the grid size the same way for both by using just step rather than X step and Y step. This just makes both of them to be 0.5. So here we show a little 4x4 grid that goes from 0, 0 to 2, 2. Now funny things happen when we start at a different point. Suppose we don't start at 0, 0. So let's paste a little segment of code here. The only thing that's different is we're starting at coordinate 3, 0. When we compile this, we see that the left-hand edge is missing. This is actually a bug, in my opinion, in TikZ. I link to the Stack Exchange discussion in the show notes. We can fix that by using Shift instead of specifying an explicit starting point. So here we're going to redraw it. We'll shift to 6, 0, and then we'll use the same grid command as before. What happens when we do that? Then we are not missing the left-hand edge. So the workaround is a shift instead of a starting point. I hope you've enjoyed today's video. We've seen how to create grids, and I would generally recommend using a shift to specify the starting point of the grid rather than an explicit starting coordinate. I hope you have some idea why that is now. This is the last video in our series on TikZ paths. This is the starting point for any TikZ exploration. But I'm very excited to get on to an entirely new series of videos covering TikZ nodes, which is how you get text and many other interesting objects into your TikZ diagrams. Stay tuned. There's a link to the Overleaf document we created today in the show notes. Please click like or subscribe if you want more videos like this. You can also buy my book, Unlocking LaTeX Graphics, at your favorite book retailer. Thanks for watching.